Section 9.3 is on geometric sequences. A geometric sequence is a sequence in which the ratio of any term to its preceding term is a constant value, which is called the common ratio. So the nth term of a geometric sequence is a sub n equals a sub 1 times r raised to the power of n minus 1, where a sub n is the nth term, a sub 1 is the first term, n is the number of the term, and r is the common ratio. Let's take a look at a couple examples. Our first one says, is the sequence negative 1, 1, negative 1, 1, and so on geometric? If so, state the common ratio. So in other words, is the second term divided by the first term the same as the third term divided by the second term, and so on? So 1 over negative 1's second term divided by the first term is equal to negative 1. The third term divided by the second term is equal to negative 1, and I can see that that's going to continue. So yes, this is geometric because there is a constant number that is constantly being divided each time, and my common ratio is going to be negative 1 because when I take the second term and divide it by the first and the third term and divide it by the second and so on, I get the common ratio of negative 1. Second example says find the eighth term of the sequence, negative 3, 6, negative 12, and so on. So let's go ahead and define some of these terms. I know that the first term is negative 3. My common ratio, I'm going to do 6 divided by negative 3. So my common ratio is negative 2. And I need to find the eighth term. So let's plug that into our formula. Remember, our formula was a sub n equals a sub 1 times r to the n minus 1. So the eighth term is a sub 8 equals negative 3. I'm going to go ahead and put that in parentheses, times the common ratio, which is negative 2, raised to the power of 8 minus 1. Now remember your order of operations. I need to evaluate the exponent first. So that's going to be negative 3 times negative 2 to the 7th. And then when I put that into my calculator, I get that that equals 384. In a geometric sequence, the square of the middle term of any three consecutive terms is equal to the product of the other two terms. This is called the geometric mean. The geometric mean of two positive numbers, x and y, is the square root of x times y. Note that by definition, the geometric mean is positive, but it is possible that the middle term could be negative. So next example says find the missing term of the geometric sequence 2/5, and there's my blank term, and 8 over 45. So the geometric mean is going to be the square root of 2/5 times 8 over 45, which is equal to the square root of 16 over 225, and both of those are perfect squares, and that's equal to 4 over 15. And our last example says write an explicit formula for the sequence that has a sub 1 equal to 1 and r equal to 0.5. Then find the first 5 terms. So my formula would be a sub n equals a sub 1, which is 1, times my common ratio, 0.5, raised to the n minus 1. And then to find the first 5 terms, I would just plug in each number. So a sub 1 is going to be 1 times 0.5 to the 1 minus 1. Anything raised to the 0 power is 1, so 1 times 1 is 1. A sub 2 is going to be 1 times 0.5 to the 2 minus 1, which is going to be 0.5 to the 1, or 0.5. A sub 3, 1 times 0.5 to the 3 minus 1, which is going to be 0.5 squared, or 0.25. A sub 4 to the 4 minus 1, and that ends up being 0.125, and a sub 5, the fifth term of the sequence, is going to be equal to 0.0625. So in this section, we took a look at geometric sequences and the formula that we can use to find them, and also discussed the geometric mean, how to write an explicit formula, and then find the nth term.